And hello. Now we're on to question 8 of 1A of linear algebra done right. So this time we're showing that for all alpha in the complex numbers, alpha cannot be 0, so that's not what we're showing that, but where alpha isn't 0, that there exists a unique. Remember, this indicates to us that first we need to prove it exists, and then second that it's unique. So there exists a unique beta in the complex numbers such that alpha times beta, so alpha is a complex number and beta is a complex number, equals 1. So first I want you to notice that means beta is going to be a multiplicative inverse of alpha. That's I think it's 2 pages before the exercises where you can find that definition in the textbook. So knowing that it's a multiplicative inverse, we can prove that beta must exist. So we let beta equal 1 over alpha, which is a multiplicative inverse. And the left-hand side of alpha times beta equals 1 is alpha times beta, which equals now alpha times 1 over alpha, because we set beta to 1 over alpha, which equals 1, which equals the right-hand side as required. And we can do this because the multiplicative inverse has been defined. But now we need to prove that it's unique. So there's no definition that it has to be unique. So we're going to suppose the contrary. So we're going to do a contradiction here. So same as the last question, we're going to assume there exists a beta and beta prime that are complex numbers such that alpha times beta equals 1. I'm just going to fix that there. And alpha times beta prime equals 1. Okay. Then alpha times beta must be 1, and alpha times beta prime must also equal 1. And beta cannot equal beta prime because they need to be different. So then we get alpha times beta equals alpha times beta prime. Because they both equal 1, we can set them equal to each other. Then we can factor out alpha by reversing the distributive property in complex numbers. And since alpha cannot equal 0, beta minus beta prime must equal 0. Therefore, beta equals beta prime by adding beta prime to both sides, which is a contradiction because it can't equal beta prime in order for there to be more than one solution. So it must be unique. And that's the end of question 8. I'll see you in the next one.